Why does my focuser keep disconnecting? That's ridiculous.
When do you finish cooking?
6:30:22.
I'm gonna lay down with him and see if he'll sleep.
Okay.
Are you streaming yet?
Yep, just starting.
You want to say goodnight to him?
Good night, buddy. Love you. Let's get some sleep, okay? Good night. Love you. Okay. Gonna try again. Hopefully we have success a little bit earlier. I learned some things last time, and that is my telescope does not like to do what Nina tells it to. For some reason, the sync and slew does not work very well with Nina, so I have to go and slew with a different program. Excuse me, to get it to go exactly where I want it to go. But I've pulled up the ephemeris off of the JPL Horizons website, and it is currently 2 a.m. January 8th UTC. So we will be at 6:30:22 right ascension. Stop guiding. It's in the ballpark now because I was messing around with trying to get the trying to figure out how to get it to slew where I needed it to go. Was that 6:30? 6:30:22. Right ascension and declination is 1 degree 26 minutes 26 seconds. 1 degree 20 minutes. That's close. Okay, slew to target. Okay. Now, the thing about tonight is that the telescope is not moving a lot. Its apparent motion is going to be minimal. It's not moving very much. So we're gonna have to take quite a few exposures, or maybe like over a 5 or 10 minute period. Take like 5 or 10 1 minute exposures, and then blink through those and see if we can find it. But we should be on target now. So we'll go ahead and loop, save, and just start doing 1 minute exposures here. And see if we can see it moving. The Webb telescope is currently 652,354 miles away from Earth. And it's got 246,353 miles to go. It just folded out the left side, the port primary mirror. Let's watch. Ooh. That's beautiful. What a crazy contraption, man. Okay, first exposure is done. It should be pretty close to the middle of the frame because I've got the... It should be slewing more accurately now. Cyber Freak. I'm here, the noob. Hi, Dad. And hi, Claps Destiny. How are you? Who's Cyber Freak? Is that you, Hannah? No, search an image. We're spying. We're spying on the James Webb telescope. Some telescope on telescope action. I'm doing good, Clap Z. Thank you. Should I call you Clap Z or Destiny? Violet, why are you out of bed?
I want to sleep on the couch.
You cannot sleep on the couch.
Shaking.
No, you cannot.
Shaking.
No, you cannot. Go back to your bed, please. So I'm just going to let it pile up like 5 of these exposures, and then we'll go blink through it. And see if we can see it moving. It should be pretty close to the center of the frame. I should do a plate solve first. Let me just do a plate solve and make sure we are on the money here. Seesaw, and it's confusing. Claps. Okay. Gotcha, Claps. Well, I'm glad you're here. We're going to try to find the James Webb Space Telescope. All right. So we got 6, 29, 14, 1, 27, 37. See, the sync command is not working. 629. Yeah, it's still at... See, the plate solved at 629.14, and it's still showing 630.23 right ascension. So for some reason, Nina is not syncing my scope. That's the problem. 629.14. Where is 629.14? How far off is that? 630. So we're almost a whole minute off in right ascension. So it's not going to be dead center. Commence imaging. So it's probably going to be like a little bit, let's see, 629. That's going to be, it's probably going to be a little bit to the left of dead center. How far off was the right ascension? I mean the declination, 127.37. Or 127.37, 126. So it's going to be below. Okay, so it's going to be a little bit to the left and a little bit below of dead center. It should be, anyways. Maybe like right here somewhere. But yeah, anyways, we will stack up a few of these exposures and see if we can find it. Yeah, I don't know, honey. Now, the last time we did this, it was a lot higher magnitude than I was expecting it to be. It was faint, and it was not easy to find. It's probably going to be even harder this time, but I've got a better idea of where it's going to be this time, so it might be easier. We will we'll wait for one more of these exposures to come in. And then I'm going to also go do a star alignment on them. So the stars will be nice and stable. That'll make it a lot easier. 8th grade, I'm selecting my electives for high school. I'm going to pick astronomy for one of them. That's awesome. Yeah, good luck with that. Astronomy is amazing. That's um, at first blush, it seems kind of like navel gazing. What can you learn just by looking at stuff that's so far away? But you can really, when you start getting more advanced, the scientists that study this stuff, they learn a lot from just looking at the stars out there. That's how the first determination of the speed of light was made, by watching the moons of Jupiter. And I mean, there's so much you can infer from the way the universe works just by looking at what's going on out there. Yes, Violet, what is it? No, I'm not reading that sign. Go to sleep. All right, after this one clocks in, we'll go into PixInsight and load them up and see if we can see it moving. Okay, process, image registration, star alignment. Okay, so the first thing I'm going to do is align all of these files. I'll align all the stars in these so that the stars are really stable, and that'll make it easier that'll make the telescope stick out more if the stars are all really nice and stable here. Section 3, select folder. So we'll go ahead, and this part of PixInsight looks at the stars and matches them up, and registers all the images to be aligned. All the stars will be aligned in all these images, so that when we flip through them fast, the stars will stay perfectly still, and then the telescope will stick out more. Okay, now this will flip through all these images, and if it's in here and it's moving, we should see it moving. But like I said, I'm not sure it's going to be moving much. I think the apparent motion is going to be pretty low. So we might have to stack up quite a few exposures before we see it moving significantly. And it's going to be a small, faint dot. Maybe let's blink them faster here. That might be it right there. Maybe not. I don't know. I don't really know what to expect for how much it's going to be moving. I just know it's not going to be much compared to how much it's been moving recently. Yeah. No, it does not. Yeah, sorry, my baby's not happy right now. Planetary science, exoplanets. Oh yeah, yeah, that's a interferometry. Yeah, how you take several images and look for the way the planet affects the light of the stars. Yeah, yeah, that's good stuff. Or not? That's not interferometry. Okay, sorry. Forget I said interferometry is using two signals and looking at the interference between them and extracting data from that. Huh. Well, it's got to be here somewhere. And it shouldn't be very far off from the dead center of the frame. When you're just starting to look for it, it could be like right in front of one of these big stars or something. That's always a possibility. If you're just joining right now, I've taken 3 images and I'm blinking them on the screen in rapid succession to see if we can see the motion of the telescope. Because it's just going to be a white dot. It's going to look like a star. So the only way to know you're looking at it is to look for its motion. This this is what I saw before. That is potentially it. So as I'm looking for it in these first three exposures, um, the computer out in the observatory is gathering, more and more exposures. It's still a, oh geez, what the heck is that? Okay. What happened? My mount still has sand in it from when I did you see something move, Cyber Freak? Where do you see it? My mount I took it camping last year and it got all this super fine dust sand in it. And I've cleaned it out a couple of times, but it still gets little grains in it, I think, and that's what it does when that happens. They get between the teeth and the gears, and it does that. Let's see if it did. Yeah, yeah. That was a potential candidate, I think, Cyber Freak. Because it's not going to be moving much, so we're going to have to watch for a while and build up exposures. Let me see. So 211018 was the last one here. Let's add the ones we've gathered since then. 211018. So we've done these ones. Let's add and register those. Overwrite existing files. So I'm going to register those, the new ones that we just took. And then we'll blink through those again. Yeah. Yeah, Cyber Freak. I think that was close. Yeah, I've got an observatory in my yard that I built last year. Um yeah, well, it's out in my yard. I've got an 11-inch Edge HD telescope on there. It's all computer controlled. I'm controlling it from inside my house. It's got, a motorized dome and everything over it. I can probably, well, let me see. Hello, infamous Rebel 199. And how do you know my name is Jay? Who are you? Let me try to find a picture of my observatory here. Wait, I hear my guiding beeping. Yep, dang it, that's stupid. Whoops, that was the wrong way. My mouse got sand in it, and it keeps throwing its it keeps making the gears jump to the side. Hopefully it only does this a couple of times. Sometimes I get to a real bad spot, and it'll do it all the time, and it gets extremely frustrating. Alright. And it throws it off so far that it loses the guiding, and then I have to manually guide it back. Okay, but all those images are registered. Let's open them up and blink. Now, some of these are bad, obviously. And we will get rid of the bad ones. Because of the sand. There. Okay, so these two are bad. Get rid of them! Okay. Now let's watch all of these and see if we see anything. So it's blinking through all of the recent images. That one potential candidate was right around here somewhere. Could have just been like a trick of diffraction too, you know. Well, there it is. There it is. That's definitely it. Nice. Okay, there she is. The James Webb. And it's moving the right direction too. It's going right across the frame. So we will just capture a bunch of these and make a little video. Okay, so there it is. We have located the James Webb Space Telescope. It's not too far off from the center of the frame. Oh, hi Ricky and Ashley. Nice to see you. This little moving dot here is the James Webb Space Telescope, heading out to its final destination. How far away is that moving dot from us? 652,000 miles. Going at 0.25 miles per second. It's slowed down quite a bit. Okay, so let's try to... It's right in that triangle of... It's right in this triangle of bright stars. Yeah, right there. So let's go back to the live view from the telescope. It's right here. So we should see it move here. Hey, where'd it go? Okay, so these three, and so like this is it right here. Okay, this is the James Webb Space Telescope in real time. I think. I think that's the dot. All these dots look the same. Its final destination is an interesting place called a Lagrange point, and that's where the gravity of the sun and the Earth kind of all balance out and enable it to. Yep, that's it right there. It moved and enable it to like use the least amount of fuel possible to stay right to keep the Earth right between itself and the sun, um, and orbit with the Earth. Like if I'm the sun, here's the Earth, here's the James Webb Space Telescope, and it'll orbit like this because its orbit has a point of equilibrium between the gravity of the Earth and the sun, and it's just kind of this place where it's easy for it to hover out there. Um, but yeah, that's called the Lagrange point, and it's gonna hover out there. So it's I don't know if it's exactly orbiting the Earth or orbiting the sun or kind of both, but I think it's doing a little of both. Yep, we saw it move there. That's awesome. Okay. Well, it only took what time is it? Okay, it only took like 20 minutes to find it this time. It took like an hour last time. So that's a lot better. Yeah, it's about a million miles, give or take. Or I don't know, maybe a little, I don't remember. But yeah, its apparent motion is definitely a lot less than it was before. Like before I was doing 1 minute exposures, it was making much bigger jumps. And now it's only, it's not even the width of the dot. And it's definitely fainter than it was last time too. It's gonna be when it's all the way out there, it's gonna be hard to see. Bloop. Oh, that's cool. Wish I could put some kind of mark on this screen so I could remember where it is. Because if I zoom out and zoom, well, it's not that hard to figure out now because we got this nice little triangle right around it. But yeah, that is extremely faint. I want to go into like go into Stellarium and like figure out what the magnitude. It's like it's about the same as these stars here. Like figure out what the magnitude of these are, and then that'll tell us what the magnitude of the James Webb scope is. I don't know if I can do that right now. Let me try. Let's try it right now. Stellarium does not play well with OBS, the streaming program that I use, so my screen might blank out. But let's see. Uh, 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 uh. We're over here somewhere. Let's see here. No, why did you do that? Stop it. Stop. I'm not very experienced with Stellarium. So bear with me a minute. So why? Okay, there. So we've got 6 hours. We were at like 6 hours 29 minutes. Declination, and then like 1 degree and whatever. Okay, let me look up the exact coordinates here again. Oh, you SOB. God bless America. As long as it can find its way back. I gotta. The grease might be old and sticky too. You know how long it's gonna take for it to reach? Oh, yeah, actually. It's going to take 29 days. So we're at 13 days. So we got 16 more days to go. A little over 2 more weeks, and then it'll get there. And then they're doing a bunch of mirror alignment testing, blah, blah, blah. It's going to take a very long time. And I hope my mount quits doing this because it's screwing everything up. My grease might be old and extremely cold too. So as soon as the weather gets nicer, I gotta tear that thing down. When we got a big stretch of bad weather, I'll tear it down. Okay, right now we are at 234. So we got 082 34. Its current coordinates are 63017. And 126.44. So 63017 and 126.44. Oh, I gotta remember that my telescope flips them left to right too. Okay, yeah, and these are those 3 stars. Let's pull it up again, and my telescope flips it left to right. Get a decent exposure here. Okay, so this is it right here. So we've got these 3 stars and then 3 more stars, and it's right in the middle of those. So these 3 stars, uh, gee, I don't know. Not, is it these 3 that are the others? No. So it's like this. So that means it's got to be like, okay, it's these 3, and then, okay, yeah, I see it, I see it, I see it. So it's these, and then, okay, it's like the same brightness as this thing right here. Magnitude almost 18. Yeah, that's about what I guessed. So yeah, it's about magnitude 18 right now, maybe even slightly less. Maybe magnitude 18 and a half. Because, wait, which one did I look at? Anyways, it's getting pretty dim. G Skyer 25mm telescope? That's cool. Do you use it much? The best telescope is one you use. Why did I just lose my connection? What's going on here? Well, it looks like I'm gonna have to throw some exposures out for sand in the gears, but other than that, it seems to be going pretty well. Yeah, these three. Oh no, it's these three. And then, yeah. And yeah, these three right here are these three right here. And this one is this one. And it's right here in the middle. And it's about the same brightness as this one under it. So maybe this one. Magnitude, 1550. Yeah, I've got this Cassiopeia looking thing right here, and then it's the one right under. And it's flipped left to right, so it's ding, 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 and then it's this one right here. So yeah, it's about the same brightness as this one. It looks brighter in this exposure than it did before, though. The other one, it looked a lot dimmer. I wonder if it's just the way it's catching the sun differently now, or I don't know. Maybe it was just a trick of the atmosphere. Always possible. Do I think it's a good telescope, or should I get a different one? I don't know what kind of telescope that is. 25 millimeter. Well, if it's probably a good telescope for like looking at the moon and exploring the craters, and you can see the moons of Jupiter with it. You might even be able to see a hint of the cloud bands on a really nice day. You can see the shape of Saturn. It'll be a lot of fun to just poke around with it, look at some double stars and things like that. Um, but it's people always ask, what's a good telescope? A good telescope is one you enjoy using. You could spend $100 on a telescope. You could spend $100 million on a telescope. It just, do you have fun with it? Do you learn with it? That's all. That's what a good telescope is. Um, if you start getting serious, you always get more and more. I don't know. I've got an 11-inch SCT. I don't know if I'm ever going to get a bigger one. I have plenty of fun with it. I need to improve my observatory a lot. It looks like there's just wires everywhere. It's just hacked together to get it working, but it's not a finished product. I would like to have people over and have the big monitor up out there and do like star parties and things like that, but it is completely utilitarian right now, and I need to polish it up. Yeah, I keep I lost connection for a minute. The stream was lagging a bit. My internet is like a T-Mobile wireless internet, because I live down like a remote dead end street, and there's nothing down here. We have like a little copper phone line down here. I can't get cable, I can't get fiber or anything down here. So, and up then T-Mobile just rolled out this internet service. Up until this time, we had nothing. I had to use a VPN and hack my tethering to get internet off my phone. It was ugly, dark times. But now we actually have internet now, so I can do things like stream. I think I lived here for 10 years with no internet. A good You start getting serious. Nice joke. It's nice that it's right between this nice triangle of stars. It's easy to lose track of that stupid little thing because this dot looks a lot like this dot and this dot and this dot and this dot, and it all looks the same, but one of them's moving. That's kind of the fun challenge of something like this. It's also fun to find like the minor planetoids and stuff like this. I'm gonna have to babysit this thing though because the stupid. I don't know if the sand in there is gonna keep jacking up the guiding. Good telescope. I'm sorry, I got distracted. A good. How much detail do you want to see in Saturn's rings? You could see Saturn's rings with a 300 millimeter camera lens, or or a $100. My I got this. I got it. I don't know. I don't want to mess. I'll mess with it. I don't know if you'll be able to see it, but my office is a disaster too. But anyways, there's a an 8-inch um Dobsonian over there. I got that 8-inch Dob for $100 off of a garage sale site, and that thing can see Saturn's rings pretty well. You can see the Cassini division easily on a good night. See, when you're talking about planetary viewing, um, the atmosphere is everything. You need a very nice stable atmosphere because a really nice telescope will not see crap if the atmosphere is unstable. So, a cheap telescope could see quite a bit of detail in the planets when you've got nice stable atmosphere. So, um, you can see Saturn's rings clearly with just about anything. But if you want to, if you want to resolve the Cassini division, or even like the Encke minima, or start trying to like resolve the polar hexagon, it depends on what you mean with by seeing. You know, um, let's see if let me see if I can pull up my pictures of Saturn.